Every year, thousands of tons of rock are torn from the earth in pursuit of one of humanity's most enduring treasures, silver. From deep underground tunnels to roaring smelters, this brilliant metal begins its life not as something shining, but as raw, gray ore buried in darkness. Inside these mines, precision meets power. Drills carve, explosives blast, and massive loaders carry away the shattered rock, the first step in silver's long journey from stone to wealth. Through crushing, refining, and casting, that dull ore will soon transform into the gleaming bars that fuel global trade, technology, and art. So, how does a hidden vein beneath the earth become one of the world's most valuable metals? Stay until the end as we uncover the entire process of silver, from ore to wealth. For centuries, silver has been more than a metal. It has been a mirror reflecting civilization's progress. In 2025, global silver mine production is projected to reach around 26,300 metric tons, roughly 844 million ounces, powering industries from solar panels and electronics to jewelry and currency reserves. But the road from ore to finished silver is growing more demanding. Rising energy costs, stricter environmental rules, and the world's expanding appetite for clean technology are testing the limits of global supply. The question now stands: can the world continue extracting silver fast enough to fuel the clean energy revolution? Or will the pursuit of progress drain the very resources that sustain it? Every day, over 5,000 tons of rock are blasted from underground mines to reach silver ore. Drilling rigs bore precise holes into hard rock, and timed explosives break it apart. After blasting, heavy loaders scoop the broken material and dump it into massive haul trucks, each carrying over 200 tons. These trucks move non-stop to the primary crusher, where the ore is reduced to smaller, workable fragments for processing. From here, the silver extraction process begins at full industrial scale. Inside the crushing facility, conveyor belts move the ore into powerful grinding mills. These mills, lined with heavy steel balls, spin continuously to reduce the rock into fine powder. This mechanical process frees silver-bearing minerals from the surrounding waste rock. Once pulverized, water is added to form a thick slurry, preparing the material for chemical separation. The slurry flows into containment tanks, where every ton processed may hold only a few hundred grams of silver, yet every trace counts. In the flotation stage, large vats mix the slurry with chemical reagents and air. The air bubbles attach to silver particles, carrying them upward as metallic foam. Operators skim this foam from the surface, collecting a concentrate that's several thousand times richer in silver content than the original rock. This step turns crushed waste into valuable mineral concentrate. However, the concentrate still contains impurities, which must be removed through high-temperature refining and advanced chemical treatment in the next stages. The collected silver concentrate is filtered to remove excess water, forming a dense gray sludge. Industrial dryers apply extreme heat to eliminate all remaining moisture, leaving behind a fine, heavy powder. Conveyor systems automatically fill large metal containers with the dried concentrate, each batch carefully labeled and recorded. The silver content determines each load's value, and every shipment undergoes quality checks to confirm purity before leaving the site. Once cleared, it's prepared for long-distance transport to refining facilities. Fully sealed containers of silver concentrate are loaded onto heavy trucks for delivery to refineries, sometimes traveling hundreds of kilometers. Each shipment is weighed and documented using digital tracking systems to prevent contamination or loss. The material now holds concentrated silver ready for purification. What began as tons of rough rock has now been condensed into a high-value mineral product. The next phase, smelting and refining, will transform this concentrate into pure, market-grade silver bars. At the refinery, silver concentrate is unloaded and sent directly to smelting furnaces. Massive induction furnaces heat the material above 1,000 degrees Celsius, melting everything into a dense, molten mixture. Flux compounds like silica and soda ash are added to bind impurities. As the furnace roars, unwanted metals separate and float as slag, leaving molten silver at the bottom. Operators tap the furnace, draining pure metal into molds. This process marks the separation of usable silver from waste materials. The molten silver cools into rough metal bars called doré bars, a semi-pure form containing traces of gold, copper, and lead. Each bar is weighed, stamped, and transferred to electrolytic refining tanks. Here, electricity does the precision work. A current passes through a silver nitrate solution, dissolving impure silver from the anode and redepositing pure silver on the cathode. Over several days, this process produces silver with a purity level reaching 99.9%, ready for industrial and commercial use. After electrolysis, the pure silver crystals are carefully scraped off the cathode plates. These crystals are washed, dried, and melted again in small induction furnaces. The molten silver is then cast into uniform molds to produce high-purity bars. Each bar is cooled, solidified, and cleaned to remove surface oxides. Inspectors measure and verify every batch using digital spectrometers. Precision is critical here. Even a fraction of impurity can downgrade the bar's grade or reject an entire production line. Every refined bar is weighed and assigned a serial number for traceability. Automated robotic arms stamp each with weight, purity, and refinery mark. Bars that meet specifications are stacked onto stainless steel pallets and moved to secure vaults. Quality control teams perform random checks on sample bars, ensuring all meet international standards. Each bar carries documentation that follows it through global distribution. This guarantees that every piece of silver can be traced back to its production source. From molten metal to certified bars, the refining process transforms raw ore into a tradable commodity. Each facility can produce thousands of silver bars weekly, supplying manufacturers, jewelers, and investors worldwide. Before leaving the refinery, bars are vacuum sealed to prevent oxidation during shipment. Trucks, guarded and GPS tracked, deliver them to distribution centers or financial institutions. This marks the end of refining, the moment silver officially becomes one of the world's most recognized precious metals. Inside industrial plants, refined silver bars are melted again in electric furnaces, reaching over 1,200 degrees Celsius. The molten metal is poured into continuous casting machines that form long rods or thin sheets, depending on their end use. These are cut into precise lengths, cooled, and rolled into uniform dimensions. This stage defines the silver's mechanical properties: flexibility, conductivity, and purity. Every roll or rod is then tested under automated sensors before moving to the next processing stage for specialized applications. Silver rods are transported to wire drawing machines, where they're pulled through hardened steel dies to create extremely thin wires. These wires are used in electrical circuits, solar panels, and battery connectors. Each strand undergoes resistance testing to ensure stable conductivity. Even microscopic inconsistencies can cause power loss or short circuits. After passing inspection, the wires are coiled, labeled, and packed for shipment to electronic component manufacturers across multiple industries. For industrial coatings, silver sheets are sliced into thin foils and applied to glass or ceramic surfaces using high-temperature vacuum deposition. This gives mirrors their reflective finish and enables conductive layers in touchscreens. The process takes place in clean rooms to prevent contamination. Each coated surface is visually and digitally inspected for uniform thickness. The result is a precision layer, just microns thick, that reflects light perfectly or transmits current efficiently across electronic devices. Medical-grade silver follows a separate production line. Here, silver powder is blended with polymers and compressed into sterilized parts used in wound dressings and surgical instruments. Its antimicrobial properties are activated during the molding process. Each batch is lab-tested for purity and performance to ensure safety. Hospitals and healthcare manufacturers rely on this exacting production standard to prevent infection and improve healing, making silver one of the few metals directly trusted inside the human body. In the final stage of manufacturing, leftover silver scrap from wire trimming and coating is collected, melted, and recast into new bars. Nothing goes to waste. Recycling within the plant maintains production efficiency and resource conservation. Each cycle of reuse reduces material loss and keeps silver flowing through industrial supply chains. By the end of this stage, the metal has been transformed from mined ore into critical components that power technology, medicine, and modern life. Before any silver leaves the refinery, every batch undergoes precise testing to verify purity and consistency. Samples are taken from each melted bar and analyzed using X-ray fluorescence and spectrometry. These machines detect even microscopic traces of other metals. The goal: reach a minimum purity of 99.9%. Bars that fall below standard are remelted and refined again until they meet exact industry specifications. This strict testing ensures that only the highest grade silver proceeds to certification. Each silver bar is then weighed, stamped, and given a unique serial number. Laser engravers mark details such as purity level, refinery name, and production date. The markings serve as a permanent record of origin and quality. Inspectors confirm that each bar's weight and surface finish meet international standards. A single defect, even a small air pocket, can result in rejection. Once approved, the bars are officially registered and stored under secure supervision. Third-party auditors perform random inspections to maintain transparency in global trading. These auditors verify purity certificates and cross-check production logs. The process is vital for trust in international markets, especially for silver used in financial investments. Each verified bar is sealed in tamper-proof packaging with its authentication card. This certification guarantees its legitimacy across borders, allowing it to be traded or stored in bullion reserves. For industrial silver, quality control shifts toward performance testing. Samples from each production batch are tested for conductivity, flexibility, and corrosion resistance. In laboratories, technicians expose the silver to simulated environmental conditions, heat, moisture, and vibration, ensuring reliability in demanding applications. These results determine where each batch will be used: electronics, solar panels, or medical manufacturing. High-performance grades are prioritized for precision industries that require exact tolerances. Finally, approved silver is stored in climate-controlled vaults or transferred directly to industrial buyers. Security systems track every movement from storage to transport. Each shipment is digitally logged, ensuring full traceability from mine to market. Only after passing all certifications can the silver officially enter global circulation, ready to serve in manufacturing, technology, investment, and trade. Inside the refinery's final zone, molten silver flows into molds lined with graphite. Each mold is precisely measured to form 1,000-ounce bars. Automated arms pour and level the glowing metal, while cooling jets rapidly solidify the surface. Within minutes, each bar hardens to a perfect metallic finish. Sensors scan for cracks or surface flaws. Any defect, no matter how small, sends the bar back for remelting. Only flawless bars advance to stamping and certification, where their identity begins. As the bars cool, robotic presses engrave serial numbers, purity grades, and refinery marks. These stamps confirm authenticity for trading and export. Laser analyzers then verify silver content, ensuring it meets 99.9% purity or higher. Bars that pass are automatically sorted and stacked by robotic handlers. Every move is digitally logged, providing full traceability from mine to vault. The process eliminates human error while maintaining international trading standards. Next, forklift systems transfer the verified bars into armored transport containers. Each load is sealed, tagged, and assigned GPS tracking. These shipments travel under strict security protocols to national mints, industrial clients, or private investors. Inside these facilities, silver undergoes another transformation, melted again to make coins, electrical contacts, and high-precision components for modern devices. Every ounce must meet technical specifications before entering production lines. In the minting process, refined silver is rolled into thin sheets and punched into blanks. These blanks are polished, engraved, and pressed into coins or commemorative medallions. Meanwhile, industrial-grade silver is alloyed or vaporized for specialized uses, from solar panels to precision circuits. Each step maximizes utility, ensuring no metal is wasted. What began as rock beneath the earth now fuels both economy and technology in its purest form. Finally, distributors ship finished products worldwide. Bars and coins are traded through global exchanges, while industrial-grade silver powers electronics, mirrors, and medical instruments. Recycling plants reclaim scrap silver from used components, reintroducing it into the production loop. The cycle repeats endlessly: mining, refining, shaping, and reusing. From raw ore to high-value metal, this continuous chain keeps modern industries alive, one polished bar at a time. If seeing how raw rock becomes pure silver bars changed how you look at the metals shaping our world, share this video and tap the bell so you never miss how the world's industries are built from start to finish. Next, we'll uncover how discarded metal finds new life, melted, purified, and forged again to power the future. Don't miss the full transformation in how billions of tons of copper are recycled from scrap to power.